Announced that iOS 8 will be coming out in a few months. Just checking it out. Okay, now that we're on the midterm, so I'm going to send out instructions on Piazza on how you can get a soft copy of your the PDF of your midterms. Okay, I'm also going to add a sample solution on Connect for you to have a see of my sample solution. And if you want your exam regraded, I only do entire exam regrades. Okay, so if you want the full exam to be regraded, you'll tell me and I'll regrade everything myself. You might go up, you might go down. Right, so I'm not just going to look at one question. I'm going to ask you to tell me in your email which question it is that you have most trouble with, but I'm going to regrade the whole thing. Any questions? Alright, so let's talk about nested queries. Let's assume that I want to find the name of stars who've been in a movie with ID 28. Okay, so nested queries allows me to run one query inside another query. Okay, so my where clause here is itself another SQL query that has select from where. You can think of this as nested loops in programming, or you can assume that this is a function that this query is calling. You can have the nested query as part of the where clause. You can also have it as part of the from clause. Now, to understand nested queries, basically what this is going to do is it's going to say, for each movie star tuple, check the qualification by computing the subquery. So for each line, for each tuple, it's going to check based on this query to see whether the m.star ID is inside there or not. Okay, so if you run that select s.star ID from stars in S where movie ID is 28, these are the star IDs that you're going to get back. Then basically what this is saying is that select m name from movie star where MID is in this set of values. It's either 1026 or it's 1027. One thing to note is that the nested query will be evaluated once for each tuple in movie star. Here, the nested query, the one which is inside, does not have any correlation with the one which is running outside. Right? So there's no part of the outer query which is being used inside my inner query. You can assume that you have two for loops, one running inside the other, but really there's nothing between one and the other that's no parameters that's shared between the two. Or you can assume that this is a function which really doesn't have any parameters right now. The outer one. So the outer one runs, and that one calls the inner one. Okay, so this is showing you what is happening, but this is the one that starts everything. Any questions so far? If you're using in here, where you're finding star IDs of those who've been in that movie, this could be written so much easier without a nested query. But if you use not in, so if you want to find the movie stars, the name of movie stars that were not in that movie ID, then using nested query is a good approach. Any questions? Right, then I want you to find me names of stars who have not been in the movie ID. And I'll leave the previous example up for you, so actually I can't because you need the schema. Right, so just before you start again, this is what it would look like. I have select from where, and then I have a nested query, where that nested query could run another select from where. Right, and click whenever you're finished. Okay, so this is what's going to happen when you run this query. When you run this query, you're going to start with the outer query, and that says, look in your movie star table. Okay? So it's going to go into your movie star table. And then, it's for each of the tuples here, it's going to look at that tuple, and it's going to say, is your star ID inside the second query? So now it needs to know what the second query is. It's going to call that query and it's going to say select star ID from stars in where movie ID is 276. So this is going to give you a set of star IDs, let's say A1, A2, and A3. And it's going to look at the star ID that I have for this tuple here. It's going to say, is that star ID either A1, A2, or A3? If it's not in those, then I'm going to return this. If it is any of those, then I'm not going to return this tuple. Then it goes to the second line. For the second line, it needs to run that query again. Again, it's going to look at this. It's going to calculate A1, A2, and A3, and then it's going to see whether star's ID is any of A1, A2, or A3. Read.
Could you do like the opposite? Could you do, instead of nodding, could you do in and then have where s.movie ID does not equal 276?
So use in,
Yeah.
and then do what?
And then do where s.movie ID does not equal 276, just like the complement thing?
I have a query which I'm going to ask you. So would it be like this or not?
No, no.
Not like this. You're still going to use a nested query, but you're complementing that. That would work fine.
Okay.
Question in the back.
In the inner nested query, do you actually need an alias on starsin? Since it just returns star ID to compare?
Great question. So the question is, do I need an alias in the inner one? And we're going to come back to that question in a few slides, where you have correlated queries. But here, no, it would work fine if you take it out. Now the optimizer might notice that this inner query is not taking any parameters from the outer query. Right? So this is going to be the same thing every time I do this for all these different lines. So in this example, the optimizer may just do this once and use it multiple times for different lines. But as far as we're concerned, this will be reevaluated every time you go to the next line. Any questions? Now I want you to discuss with your neighbors whether this query would do the same thing, and if it wouldn't, what would this one do? Sorry, that's cut off. It just says s.movie ID is not equal to 276.
Get 1,000 tuples and be generated.
Right, does anyone have an answer?
I think that's horrible.
Right. It's the same thing? So one answer is that it's doing the same thing. Any other answers? Yeah.
Names of movie stars, all movie stars except the people who only starred in 276.
It will give you the list of everyone. What?
Except people who only starred in 276.
Except those who only played in that movie. Any other suggestions? Okay, so let's try to figure out the first one. So the first one is saying A1 and A2 and A3, and you want people except A1, A2, and A3 to show in your list of people. Movie ID 276 is actually Black Swan in our database, and Natalie Portman played in that movie. Okay, so one of these is Natalie Portman. Now, when you run the first query, you don't want to see Natalie Portman show up. What does the second query do? The second query is going to look for all the stars that were in a movie other than 276. As it turns out, Natalie Portman had been in other movies except 276. So her name is going to show up with one other movie that she's played in. So at the end, her name will also show up in your final query. Who wouldn't show up in your final query? This person that has only played in Black Swan. And they have never, ever, ever played in anything else. This guy will not show up. Any questions? So the two queries are not the same. Now you can have nested queries that are in correlation with each other. Okay, so you can see that my first query, my alter query says select m.name from movie star M, where exists, and then I'm referring back to M in my inner query without actually defining M as part of my inner query. Here you can think of this as a function now that you have a parameter for it. Now if you go back to this, this concept here, now you're passing in a query. So when you do the first line, since you're passing a parameter b1, what might be calculated here could be a1, a2, and a3. For the next line, since now you're passing in a different parameter b2, the values that are going to be returned may be different to what you had before. So what this is going to do is it's going to do for each movie star, it's going to check if they played in that movie or not. Okay, so you can see I have movie star, and here I'm referring to that specific movie, which is coming from that tuple. If we go back, let's run this one. Okay, and one way that you know whether something is correlated or not is that here, this subquery, which is running as part of that, makes sense on its own. You can run that as its own because it's not taking any parameters from the outer query. Can I run this on its own? I don't have M defined. And if I run it all together, then that would be fine. And again, the important thing is to note is that the inner query is going to happen once for every tuple inside your relation. Any questions? Okay, so we've seen in. You can also have exists. What happens with exists is that it's going to run that inner query, and as long as it's not null, as long as something is returned, and it's not the empty set, then that exists is going to be true. Okay, so this exists is going to see what's going to be the return relation from this inner query, and as long as it's not the empty set, then something exists and that's fine. You can also have the any or all operator. Okay, so as an example, let's say you want to find movies made after Fargo. Okay, so if you want to think about this and run that, the first question is you need to know when Fargo was made, so then you can return results for movies that were built that were done after Fargo. Right? So in my inner query, I'm finding the year where Fargo was created, and then I'm doing select star movies where the year of that movie is higher than when Fargo was made. If you have multiple values that are being returned by your inner query, if you use the any operator, it's going to work as long as the value that you have outside is bigger than any of the ones inside. And if you use the all operator, that's going to mean that you're looking for movies that were done after all possible different movies that were named Fargo. So let's say there were two movies called Fargo. One was in 1970 and one was in 1990. If you do any, then it's going to return any movie that was done after 1970, because now my set has two values, 1970 and 1990, and I want it to be bigger than any of those. So if I had two Fargo movies, if I use the any operator, then movies after 1970 will be returned. If I use the all operator, then I want it to be movies that are after 1990. Any questions? Now, using nested questions is pretty complicated. Okay, so this will need quite a bit of practice from you guys. Now that we know how to do nested queries, you can actually rewrite intersection queries using nested queries. So if I want to find IDs of stars who've been in movies in both 1944 and 1974, what I can do is, in my inner query, I can find those who were in the movie in 1974. And in my outer query, I'm saying I want those that were in a movie in 1944, and also in my second query, I want those to be returned. Right? So if you want to implement intersection using nested queries, I can put one of my tables inside my inner query, the other one in the outer query, and then I want those from the outer query that are inside the inner query. Any questions? question on nested queries. Think about this on your own first. Finding it difficult, doing something like what I was doing here might help you. Okay, so let's finish the first round off in 5. 4, 3, 2, 1. Right, discuss it with your neighbors.
Yeah, you can't be concerned about it. So
But so then you can work on this and then even actions like
but you could also become it's good, you know.
Does anyone need more time?
I'm fairly sure that you can become more.
Right, let's finish this off in 5, 4, 3, 2, 1. Random quick. Alright, so let's see what this means. So, the outer query says select team and day from score S1, where runs is bigger than all of. Now let's get to the inside query. The inner query is looking for runs where S1.day equals S2.day. So what we're going to do is, we're going to go through each tuple, and then we're going to look at that day. So for that first tuple, we're going to see that's Sunday. That Sunday, that value is going to be passed into the inner query as a parameter, because I have S1.day here. And I'm going to return all the runs that are for Sunday. Okay? So all the runs for Sunday, I'm going to get 4, I'm going to get 9, I'm going to get 2, I'm going to get 7, and I'm going to get another 2. And one more 4, and one more 4. Thank you. Okay, so this is what's being returned. And now, I'm returning team and a day where runs is smaller than all of these values. So it's going to look at that first row, and it's going to say, is 4 smaller than all of these? Since I have the 2 here, 4 is not smaller than all of these, so it will not return that first row. And we'll get to that second line, it'll look at 9, 9 is not smaller than all of those, so that will not return it. You get to the third line, and 2 is smaller or equal to all of these. So it's going to return the team and the day for the third row. Because what's being found is that it's smaller or equal to all of the values that we have in that query so far. Any questions so far? So what is that actually doing? That query is looking at combinations of team day pairs such that team scored the minimum runs for that day. Right? So minimum runs for Sunday was 2, so carp and baby stars will be returned. And minimum for Monday is 0, so swallows will be returned. And if you run that query, you'll see carp sun, baby stars, sun, and swallows mun, which you can see as A, B, and C in our choices here. So D, all of the above is the right answer. Any questions? Right, so now I want you to write a nested query and find the name and age of the oldest student. So how can I find the name and age of the oldest students? Inside my inner query, I'm going to find the age of the oldest student. So I'm going to select age from students. That's going to give me age of all of my students. Now that I have age of all my students, I'm going to look and I'm going to select those where their age is bigger or equal to all of the above. Does that make sense? Question. If I change bigger or equal to all to bigger than any, what would be returned? Okay.
All the ages except I guess the lowest one.
All the students except those that have the youngest. Right? Now I have all of the ages here, and I'm returning any that's bigger than one value in here. So if the minimum here is 18, then I'm going to return all my students and their ages for people that are older than 18. Any questions? Alright, now division in SQL is quite complicated. Okay, so hence, anything related to division in SQL, you will not be tested on exams. However, if you read your project, you need to have one query which is using division. Okay, so I'm going to test you on division only in your project and not in your final exam. Now, with division, you can have queries such as find students who've taken all of the classes. Right? And if I want to write that, I can use except. I can say, let's find all of the possible courses, and let's find all the courses that my students have taken. If there's nothing that is offered but my student hasn't taken, then that means that person has taken all of the courses. Okay, so one way that you can implement division is with nested queries in Excel. I have a nested query, and inside that inner query, I'm going to use an accept. I'm going to have all my courses. I'm going to see the ones that the students have taken, and if I find someone that have taken all of those, then that person is the person that I'm going to return. A yet more complicated way of thinking about this is nested queries within nested queries. Right? So I have a nested query, and inside that I have another query. I have a function which is calling another function which is calling another function. And this is what this is doing. This is selecting students such that there is no class which is not taken by us. Okay, so I'm finding students such that there's no class, there doesn't exist a class C which is not taken by that student. Okay, and again, this is pretty complicated SQL, and I wouldn't expect you to write such queries in your exams, but you will be tested on this as part of your project. Questions? Okay, so up to now, whatever we've seen were extensions of what we had already seen in relational algebra. For the operators that we talked about, you should be able to write queries using all of those, except division. In general, feel free to use whatever seems easiest to you, unless the question is specifically asking you to implement a query with a specific operator. Right? So I might ask you that write this query without using nested queries. Or write this, include at least one nested query inside it. If I don't tell you anything, then feel free to write it in any way that you like. Or I might say do this without doing union or intersection. Or do it with union or intersection. Now, sometimes the query optimizer runs poorly if you write maybe with nested queries instead of intersection or union, and one performs much better than the other one, and optimizer is not always intelligent enough to understand that this nested query is really similar to this intersection query that we've written. So there are methods where you can look at which one seems to be faster, but again, we're not going to worry about that. But there is more stuff that we want to do with our SQL queries that we have not talked about in relational algebra. For example, with what you know so far from relational algebra, you cannot find the average age of students. There are extensions of relational algebra that cover these topics. We're not going to worry about them. But we are going to cover them in SQL. Mike?
Oh, wait, isn't SQL incapable of doing mathematical operations though?
SQL is capable of doing mathematical operations, and that's what we're going to see. But with what you know from relational algebra, what we did with selection and projection, which was pi, with what you know so far in relational algebra, you don't know how to do aggregations. And we're not going to cover it. But we are going to cover it in SQL. Now you can have aggregate operators, such as average, min, max, sum, and count, that you might want to use inside your queries. Okay? So I want to be able to say, find me the average age of students, or what's the maximum? Now some of these, we were basically implementing ourselves here. Since we didn't know about the max operator, we were trying to use a nested query in order to implement maximum. With some of these operators, you can combine them with distinct. So if you want to count distinct number of students that you have, you can say count distinct, and then A or S num if S num is their student number. Let's see some examples. If I want to find the number of students, I can say select count star from student. And if I run that, I'm going to get back 24. One thing to note is that up to now, what I've usually been returned was I got a table back as my result. Right? I always got a table with maybe multiple attributes and multiple rows. Here, when I'm asking for the count of students, all that's being returned to me is 24. And if you check, it says that one row was returned. So it's seeing that value still as a relation. This is a relation with one row and one attribute, where the row is being count star. The second one, let's find name and age of the oldest students. For this one, I can do select name from student, where s.age equals max of s2.age from student s2. Now this one does not run on all DBMSs. Some DBMSs will not allow you to run aggregate values as part of your nested query. I believe MySQL should be fine though. Now, there was a question about using multiple copies of the same table as part of your inner query and outer query, and whether I would need two different distinct copies of that table or not. This is going to be very similar in how we use scope of variables inside your functions when you're programming. And it's going to be locality. Right? So if you have a function, if you have an inner query where m is defined as part of that inner query, then anything m dots that you have, it's going to locally look at the local m that you have inside that query. If there's also an m outside, as part of your outer query, this will be ignored if you have defined an m query inside. If you don't have this here, and you do m dot, then it's going to find the outer m, and it's going to bind it to there. Right? So if my inner query, if my nested query is correlating with the one that I have outside, then I would need to have two different copies of the tables. If there's no correlation between the two, then I can use the same name or the same table with locality taking in place, and the one which is inside is going to use its own copy. Does that answer your question you had before? Alright, now let's find the average age of our senior students, where their standing is senior. I can have a where clause where I'm just getting those people where they're standing is senior, and then I have an aggregate which is going over only those people. Right? So when you do this, first what's going to happen is that it's going to look at the where clause, and the where clause is going to say, yeah, I need this row, yeah, I don't need this one, I need this one, I don't need this one. And out of the ones that I do need, I'm going to aggregate and find the average. And I'm not going to worry about the ones that I crossed out. Alright, let's do the first one. And click when you're done. Okay, so again when I start out, I'm going to start with select from where. And when I write it, I can see that I can start with from again. Which table am I looking at? I'm looking at students. Is there any condition that I want to apply to those students? No, I just wanted to find the minimum age of all students. So at that point I can take away my where. I find it useful to start having it in, and then you can make sure that you look for any conditions that may apply, and if there are no conditions, then you can take it out. And from all your students, you want the minimum age. And again, if you run that query, only one value will be returned to you by SQL, which is the age of the smallest age. Any questions? Let's do the second one. Okay, which table do I need? Enrolled. Would I need distinct or not? I do, I don't. So, from enrolled, I'm looking for course names like database. So I want database to be in it. I don't want it to be called database. Since I could have multiple courses with database in their title, then that student could potentially take in multiple courses that have named database in it. So if I want to know how many students have taken a class with database name, I need to add that distinct there, or else I will get the wrong value. And then I'm selecting the count of that. Alright, so if we try this out, they have 5 people. Note that I can't write this distinct out here, right? The syntax is count, and then inside the parentheses I'm going to have distinct. Any question? Please make sure you go over what we did today before coming in class on Wednesday, because our lecture on Wednesday is going to rely on what we did today. All right? Have